right, so good morning. We have a great speaker for you today. We have Weldon H. McFarland. He'll be talking to us about what his work is with AnaLab. AnaLab is a real interesting place to visit. If you haven't been there, it's just down the road in Kilgore. It used to be a little lab working out of somebody's garage, and then it was a shed behind the house, and now it's grown up to be a nice, big, beautiful building that they have over there in Kilgore. They used to bring students over there when it was a shed behind the house, and I pull up by the house, and I say, Dr. DeBoer, you must have the wrong address. This is not an analytical lab, that's somebody's house. Well, you'll see, I told them, and they saw. So, interesting place to be. A lot of LeTourneau students have found their way through AnaLab over the years, working there in summers, sometimes after graduation for a few years. And I suspect we have some LeTourneau grads there now, or not right now? Or?
I think we trained them all for Eastman.
Oh, is that what happened?
I think so.
They train them too well and they go off someplace. The same thing here, you know, you get them knowing what they're doing and they go off someplace. So AnaLab and LeTourneau have a long history of working together. So if you're looking for a summer job in biology, or chemistry, or soils, or something like that, be sure to come to lunch with us after the seminar to see if we can explore those possibilities. So let's introduce our speaker today, Weldon McFarland, interesting guy. He graduated from Texas A&I. That's right, A&I, not A&M, but Texas A&I, because back in 1971 it was called not A&M, but A&I, I for industry, I've been told. So, way back in 1971. How many of you guys are born? No. Okay. So, there you go. A while back. So he got his bachelor's degree in plant and soil science in 1971 from Texas A&I in Kingsville, Texas. And then he went on there at Kingsville to get a master's in soil science. And I guess he really liked soil sciences because then he went on to College Station at Texas A&M, changed it from an M to an I in that time, and he got a PhD in soil chemistry, not soil science, but the important word there is what? Soil chemistry. Yes. All right. And so he's going to tell us today about the exciting stuff going on at AnaLab and how municipalities and stuff make sure there's no lead in your water here. Maybe he'll talk about Flint, Michigan, something like that. Maybe do that at lunch or something. All right. Okay? And other things. So let's give him a warm welcome.
Thank you very much. I think you'll be able to hear me all right. Yeah, Texas A&I is now Texas A&M Kingsville for you neophytes that are, younger than 40 years old. And but back then it was Texas A&I. Well, who am I? I'm actually the CEO of AnaLab in Kilgore, but I just became the CEO of this last year. Before then, I was just a working stiff around there, and they talked me into being on the board of directors, and then they elected me CEO. So, like I say, with the retirement of Dr. Whiteside, I took over as CEO. I also serve as a senior scientist, which means with some of our certification programs and whatever, which I'll talk to in a little bit, I oversee that particular aspect of those things. I also repair all the instruments, and that's actually the fun part of my job. Is most days, but like I say, we have a lot of instrumentation, and just like with computers or vehicles or anything else, when you turn them on, they don't always work the first time. But I do have a PhD in soil chemistry from A&M, and I worked in soil chemistry about 20 years, and I worked actually in the hard chemistry side, I call it, of the business. I worked as product development supervisor for Land O'Lakes Company, which that's the butter people, but they do have an agricultural side to them on formulation of pesticides, surfactants, and such things as that. So I've had a varied background. I guess I'm a jack of all trades, master of none. But it was, as Gary said, Dr. Whiteside started AnaLab in 1964. Like I say, actually started in a trailer first, which was about as big as for this area I'm standing. Did hay analysis. Well, over the years, we have grown to have 6 buildings. We're currently the 14th largest environmental laboratory in the United States. We have 14, big deal. Well, for Kilgore, Texas, that's pretty impressive to me. I didn't get us there, but I hope to keep us there and keep growing. We did revenue of a little over $10 million last year. For people who are in sales of products, that doesn't sound like much, but you got to remember this is all service. So we don't sell any products other than good quality answers to them. We serve a client base that includes municipalities, state agencies, private industry, and consultants, and even individuals. So we have a large, varied client base, and we get all kinds of stuff. I mean, there's certain things you have to tell people they need to go somewhere else on, but like I say, it's beyond what we do. But for the most part, we can do most tests. We offer testing on pesticides, volatile organics, semi-volatile organics, microbiological analysis, metal analysis, physical analysis, BOD, biological oxygen demand, COD, and we do a large section of our business is wet bench, and that includes anything you can just about think of that would be done on a bench at a laboratory. We, as far as the matrices we look at, we do a lot of drinking water analysis, wastewater, soils, sludges, and air. The thing at AnaLab that makes us what I feel a little different is we base this business on client service. You can't survive in this business unless you have reputable results and good client service. We analyze about 8,000 samples a month, and most of these have multiple tests on them. So like I say, when you really get down to it, that usually turns into about 1,000 or better different tests every month. We have 8 regional offices, or shipping points, 6 regional offices and 8 shipping points. We go from Louisiana, Arkansas, Oklahoma, and Texas. We really don't have much in New Mexico. We had something in Alabama for a while, didn't really work out because of the distance. But we have one laboratory. That's the difference between us and a lot of other commercial laboratories. They try to set up satellite laboratories, and we have found that that's not cost effective, and it's not good for us because, as I'll show you in a minute, we have to maintain a lot of quality control and quality assurance, and that doubles that every time you open a laboratory. We do have a few instruments. We've got 2 ICP AESs, ICP MSs, for those of you who have inductively coupled plasma. We have GCFIDs, we have GCFPDs, we have GCECDs, and HPLCs. We have regular GCMS, we have 8 of those. We have ion chromatography. We have one LCMS MS triple quad for doing liquid samples. We have continuous flow analyzers, low level mercury, regular mercury, TOX and TOC instruments, and auto titrators. Now you see why I have to work on instruments just about once or twice a week, because something's going to happen with some of those all the time. We also have various other spectrophotometers and what have you that we're in a normal laboratory setting. What is a commercial laboratory? Essentially, we will analyze samples for a fee, and we analyze these according to the client's request, using, main thing, that's a big portion, using the approved methods according to the test they request. Well, that sounds like gobbledygook, but here it is. If they come in and want a pesticide analyzed according to EPA 8141, we have the capability to do that. EPA, and which is one of our primary method, SW 846 and EPA, those have certain methodology that we have to follow. It's not a problem. It's just that it has to be done in a certain way by a certain method at a certain time from a certain bottle, taken, so forth and so on. So, but we have to make sure we can do that. When I say a reputable laboratory, because unfortunately, as if with any business, there are some shady characters in the commercial lab business. We're not one of them, but like I say, normally a good laboratory, reputable laboratory, will be certified by several state agencies, federal agencies, specific agencies like one that I failed to put on here is the Texas Railroad Commission, but because it actually falls under another one, but there are several. And we have certification and we have accreditations. They're different. Certifications mean we can run certain tests for certain people. Accreditation means that we are a member of a group that runs blind check samples 4 times a year on every matrix. We report them back, and we have to get, we try to get 100%, but it's usually well above 95% accuracy on returning these samples back to the deal. So we are constantly checking ourselves as far as our quality control and quality assurance. And I just mentioned that. Now, to give you an idea of what I'm talking about, we are accredited by the Texas Commission on Environmental Quality, the Louisiana DEQ, Oklahoma DEQ, Arkansas DEQ, Louisiana Department of Health and Hospitals. That's drinking water. That's separate from everything else. They have every state has their little eccentricities about how they structure the testing and quality of their water. Texas Department of Health, we are a lead assessor. We will go out. We have a couple of people who are certified to be able to know how to take lead samples. This is primarily for lead paint in houses, or something like that, where they need to find out if there's possibly a health risk there. And we're also ISO 17025, which is A2LA, which is another laboratory accreditation firm. 17025 means we have a lot of documents in place. Everything we do is based on what we call an SOP, Standard Operational Procedure. We have probably 1,200 of them. But each thing we do, we have to have an SOP. So when we bring new people in, such as y'all or somebody else, they can open this up and say, okay, this is how this is done. I mean, you may still need some assistance, but at least it's got kind of like a cookbook procedure of what has to be done, how it has to be done, and what makes it right and what makes it wrong. We're also, of course, certified by the EPA. We can receive foreign soil. We run soils out of Central America and Mexico occasionally. The difference being once these are through, they have to be autoclaved and disposed of, especially so we don't introduce any critters or anything into the environment up here. Mine Safety and Health Administration and the National Laboratory Environmental Accreditation Program, which is known as NELAP, and their subsidiary TNI, which is called the NELAC Institute. But this is the people who make sure, and why do we do all this thing? We have to make sure that if you run a sample at AnaLab and you take a sample at XYZ over here, you took them both the same, put them in the same bottle and whatever, you're going to get comparable answers. I'm not saying they're not going to differ by 5%, because instrumentation may differ by that much, but theoretically you should get the same answer. To give you an idea, one of the things with an environmental laboratory that's really important is how we continually keep up with samples to know that they were taken correctly, received on time, properly refrigerated, so forth and so on. So when you start that, you have sample collection. This is something that I was taught years ago. You know, the answers are no better than the sample. If you go out and scrape a little topsoil up, put it in a jar and send it in, want an analysis on it, it's not representative of that area. So it has to be a representative sample of whatever you are testing. And you start something called a chain of custody. We live and die on SOPs and COCs. COC is a chain of custody. That means that whoever took that sample starts and shows I took it at this time on this date, put it in this bottle, and so forth and so on, and that starts a chain of custody. So when that sample is then transported, transport is also part of the chain of custody. The sampler turns it over to the person transporting. Let's say it's Lone Star Overnight. They sign for it that they got this particular cooler in there, and it started out at 4 degrees C, and they haul us to the lab, and we get it into the laboratory, and first thing we do when it gets there is we look and make sure it was received at the right temperature. We sign the chain of custody, so there's never a break in who had it when. And then we have to make sure it was received at the proper temperature. The first thing the people in login have to do, we call it login, that's where they log in the samples, they have to see if there's short holding times. Because one of the other things that's always a problem is when they get the sample, the chain of receipts are received, and they check it for temperature, the bottle and everything, then they have to look and see. Certain analytes, such as nitrate, nitrite, phosphate, several of the pesticides, they have a holding time. We have to run this, for instance, on those I just mentioned, they have to be ran within 48 hours after the time they were taken. So if they took it yesterday at 8 o'clock, we get it this morning at 8 or 9 o'clock when they come. Okay, we've already gone 27 hours out of the 48, so we've got to get that run by 8 o'clock the next morning, or it'll be out of holding time, and the answers are invalidated. Not saying they're not right, they're just not within the holding time. So if they get something with short holding time, they have to call the tech, say, hey, I've got a sample here at short holding time, you need to come pick it up. Otherwise, the samples are logged in, well, that one even too. They're logged into the laboratory data system. Again, another chain of the custody. It shows what time it was logged in by who and what have you. And then the samples go to the cooler, again, keeping the temperature at the right level of all times until the tech comes and gets it. When the tech comes and gets it, they what we call check it out. All of our samples have a barcode on them that's relative to the sample. They scan it that they took it out of the cooler, and they go use the sample, and when they take it back to the cooler, they scan it back in, so we know where that sample is at any given time within the laboratory. That is crucial, especially if you're doing any kind of work that may be litigation related. They gotta, they say, well, who says that somebody didn't come get it and dump that in it? Well, we can show who had it at which time, for how long, and throughout the whole process. So, plus the fact we need to know where it is, because sometimes tech number 2 is looking for it, and tech number 1's got it, and they don't know where it is. All they have to do is look and say, okay, so-and-so took it out, so I'll go over there and get it and scan it in. Most samples we get go through an extraction process. Okay, why? Well, there's several reasons it's for 3 reasons if you had a space in there. I didn't have my secretary proof this for me. But the primary reason, we need to separate the analyte from the matrix it's in most of the time. If it's a soil, we don't run soil per se, we run the extract from the soil. If it's water, we don't most time run the water, we run the extract from it. So we have to get it in the proper matrix. But the main reason is, with the levels that we have to meet for reporting requirements today, we have to concentrate the sample without losing any of the analytes. And sometimes that gets quite tricky, but we do monitor it throughout the process to make sure we don't. But what I'm saying is, if we get a liter of water in and you want atrazine ran on it, well, we'll actually analyze 1 mil of extract that represents that liter, because it went through an extraction process. So therefore, when we find there's 0.1 parts per million in there, that's actually 0.1 parts per billion in the sample. So that's one of the reasons we have to do it. We have to concentrate it down to get it to a level high enough we can analyze it. The other thing is we've got to put it in a matrix that's friendly to the instrumentation. You have a GC mass spec, you inject water on it, bad news. You just run the column, $800 column, probably have to have the mass spec worked on. They're designed for certain solvents to be used on them, so we have to get it in the right matrix for the instrument. The extraction, like I say, is usually one of the following: liquid. What I mean by that, we'll take methylene chloride in water, shake it, have pH adjusted, whatever. Shake it and then take the methylene chloride off of it, and any of the organics in the water went into the methylene chloride. We do that 3 times, and when we get through, we have most all of the analyte now and the methylene chloride and out of the water. That's liquid. We do solid liquid. Take 30 grams of soil and take 50 mils of acetone hexane, sonicate it, do that 3 times, filter it. Now we've got the material out of the soil, and now it's in the hexane acetone, and then we eventually get it all the way back into just hexane. So again, it's a changing of the matrix. Big thing that's come in the last 20 years that we use a lot of now is solid phase extraction, where you have a particular absorbent, let's call it, and you run the sample through there and it sticks to the absorbent from the water, and then you take a solvent and you wash it off of there. So a lot of solid phase extraction done. This is a lot simpler than the liquid, and most of the time it's just as accurate. One thing you saw on the other screen, we have several instruments that are I said we do volatile organic. Well, those are done in a special building all by themselves. You go in there and open up a felt tip pen, you just screwed up 2 days work for us, because it'll take that long to get the acetone out of it. That's how sensitive instruments are. So, but we do something called purge and trap. We take a water sample, we purge it with nitrogen, and we bubble that through there, and all the volatile organics come out, and they're trapped on a what we call a trap. Imagine that. And then we take that and heat that trap, and after we get through, and that drives them off of there, and we analyze it. So we can take stuff out of water, convert it to essentially a gas, trap it, and then convert it back to a volatile again. And the last thing is digestion. Anytime you bring in something from metals, we're going to, even though it's in a liquid form, unless you ask for it to be dissolved, we're going to run it through a digest with hydrochloric and nitric and make sure we get everything in there converted that's in there, so we can give you a total metals analysis. Once a sample is extracted, that's when the fun starts. Leading up to this, it's normally logging it in and doing the extract is normally a 1 to 2 day delay from the time the sample comes in. Some extracts are quite lengthy. Try 6 washes, reducing the volume, exchanging it into something else. So it takes a while to get that done. Once they get to the instrument, now we have the analytes in the proper matrix and concentrated. To give you an idea what has to be done before we can even run a sample, this is a GCMS example, like on a semi-volatile or volatile machine, primarily semi-volatile. We have to run what's called a tuning solution. We have to tune the mass spec and make sure it is properly tuned so it sees the proper ions and the proper concentrations from a tuning solution that we use. It happens to be DFTPP. If any of y'all have run a mass spec, you probably have done a DFTPP tune. Quality control samples have to be analyzed and passed according to method criteria. Some methods you get 10% variance, some you get 20, some you can get up to 30. Why the difference? Some analytes are really hard to analyze for. And even though we do the best we can, like every other lab, you can have a lot of times 25% variance. And like I say, so sometimes the EPA gives you that latitude. But quality control samples, this is the main difference between the reputable and the fly-by-night lab. We are very adamant that we run all QC according to all methods, and they all have to pass. or they have to pass within the limits stated by them. So until we get the QC to pass, we don't run the sample. Now, reasons for QC samples not passing? Well, it could be a lot of things, but instrument conditions may change since the last time a standard curve. We don't run a standard curve every day on most instruments. If you do, you'd spend all your time running standard curves. Most of these samples take 30 minutes to run. So you run a 6-point curve, well, there's 3 hours you've already shot of the day. But most of the time they hold a curve, what we call hold a curve, so you can run it day after day and get the same answer. But sometimes the instrument conditions will change slightly and you have to run a new standard curve. Sometimes the instruments will develop a problem, a leak, dirty inlet, broken column. You don't get any answers in. But anyway, our certain consumables need to be changed. I don't know how many of you have been around instrumentation, but there's a lot of parts to a GCMS, all of which have to be cleaned. But or you've got a major instrument problem or a major software problem. Quality control samples. This is just an idea of what has to happen before we ever run a sample. We have to run the tuning solution. That's decafluorotriphenylphosphine if you're really interested. And yeah, write that down and impress somebody later. But that's the tuning solution you use. Then we have to run an instrument blank. That's a blank that we made in the laboratory to make sure there's nothing showing up, anomalous propagation from a blank. Then we run an extraction blank. Make sure they didn't contaminate anything while they were running it, running the extraction, doing the extraction. Then we have to run what's called a CCV, a continuing calibration verification. Some of our methods have 135 analytes in a particular method. Now that's a lot of analytes to get to pass at one time. Department of Defense lets us have 2 or 3 that may be slightly outside, but within 3 sigma of the mean. But like I say, for the most part, all of them have to pass. But anyway, you run a continuing calibration verification, make sure that a 2 part per million that you use to make the curve still reads 2 parts per million when you run it again. Then we have to run an LCS-LCSD. This checks extraction. We take a laboratory control sample. If you go into liquids, we'll take a liter of water, spike it with a certain amount of analyte, and carry it through the extraction process, and we must be able to recover 85% of that at least before we can say that, okay, the extraction was representative. Then we also have to do, during the set, a matrix spike and matrix spike duplicate. We take a commercial sample that was sent to us when they send us enough, and we will spike that sample with a known amount, and we look for recovery. That is probably that's the last particular thing with the QC, but it is a very important one. So we ran all of this QC, it all passes, we've ran the data. Now what do we do with it? Well, this is, thank God for computers. This used to be done by hand, friends. When I was in, I'll age myself. When I first ran a GCMS, we had a plot recorder, and we had to measure the height and peak and calculate the areas by hand. It's a little different than that now. It's all done primarily by software. But we then download the data into something called LDS, Laboratory Data System. We wrote it ourselves. There's commercially ones available, but this one meets our needs because we wrote it the way we needed to have it. Then in this software, if we prepared the bottles right and extraction, everything right, if we had to do a dilution, all of that is taken into account, and the data is then posted and put on the analysis page of what the client will get as a report eventually. Then the instrument tech, that's what we have instrument techs 1, 2, and 3. Then we go from there to supervisors, managers, and so forth up the chain. But these are the most important people we have right here, because they're the ones that are actually generating the data. But they double check and make sure all their QC passed, all of the bottles are correct and everything. And then once they do that, they consider the set complete. It then goes to another person, a third party. I used to primarily do this, but now we have other people doing it. Somebody that did not run the instrument, did not upload the data, but is knowledgeable about it, and they double check the data to see if it looks realistic to them and to make sure all of the QC is correct. And then one last time, there's a person in the office that double checks it one last time, puts his name on it, signs it, and sends it out. So it's not as simple as it sounds. But like I say, good quality data takes a lot of effort, and we are proud to be able to the fact that we can do this. This is a long ways from running Keldall hay samples in a trailer, but we've come along kicking and screaming, but we made it. As you surmise by now, the analysis of all these things is not as simple as just getting an instrument and running it. There have to be many steps be completed correctly. One of the things that also that I didn't bring up when we were talking about accreditation and certifications, every one of those people will come to our lab at least once a year usually, sometimes twice, sometimes announced, sometimes unannounced, and will show up and say, okay, I need all your data for cyanide for the last month. We want to check this particular method out. We have to regurgitate that to them, and they go through. So we are subject to being looked at. Last month, they called me from the office and said, hey, 2 people are here from the EPA. Well, of course, your stomach always drops when you're a laboratory, because you think, oh, God, what have we done now? It wasn't us. They were checking out some data we had. They checked the data that we had sent them. There was no problem with it, but it was one of their people at a municipality that had having some problems with their quality, and they wanted to make sure that what we were saying was right before they went to them and said, what y'all are doing is wrong. So, but it worked out fine. But why all the rules and regulations? Like I said before, this data should be transportable. You should be able to take this same sample and take it to another lab, and you should get comparable results if they are a reputable lab and go through these same steps. There's going to be slight differences. I mean, everything from round-off error to maybe we had a particular analyte that was 95% accurate. They had one that was 89. Both of them passed, but ours may be. But the difference is not going to make a difference usually in whether it's within regulatory compliance or outside regulatory compliance. It's just going to make a slight difference in the number itself, because the difference, a 3 or 4% difference, is not very much. Opportunities, as Gary said, we have hired several people from Laterno over the years. They've been good employees. Unfortunately, we trained them for someone else. As with most of you, you try it here locally. You go a couple of years and you're like, wow, I bet it'd be neat to live in Dallas instead of living in Kilgore. And I can't blame you there. I mean, I live in Tyler, but anyway. But like I say, we have trained a lot of people for other people, unfortunately. But we have, within the last year since I took over, we have a profit sharing program. We have a 401k. We've got a lot of things to offer that we've never offered before. So our employee turnover has dropped tremendously. We used to hire summer interns. Not that we don't. We didn't hire any this last year because primarily we were still training some of the new people we had hired, and we didn't have any room to do any more training. We had a couple of people come over for a couple of weeks of just indoctrination. I call it that instead of training. But like I say, there is opportunities. Any reputable laboratory is always looking for people who know instrumentation, know the chemistry of extraction, and especially if you can work on an instrument. See me. Because I'm not going to be doing this anymore. It's not as difficult as it sounds. But anyway, there's always laboratories that are looking for people with the talents necessary. One of the things that I'll never when I took it, I'm going like, I'm not sure this is really worthwhile. I took a course in instrumentation when I was working on my doctorate. It was actually offered by the biology department, but we went over IR, FTIR, and all the different instrumentations that they were using. I rented GC ECD because that's what my research project was on. I developed a method of extraction for a herbicide. So, like I say, anytime you've got that kind of background, it's worth a lot to people. We currently have 3 PhDs, 10 master's degrees, and probably at least half of the other people. We have 103 employees. So we probably got at least 50 people that are BAs or BSs. Anything from biology, range science. It's not so much the degree itself, but what you brought with it. So there are opportunities out there. Like I say, this is what we're looking at. Anybody that's got experience in mass spectroscopy interpretation, instrument maintenance. The good thing, there's no 2 days that are exactly the same. Well, you say, no big deal. Well, if you ever have a job where I nearly went to work for the U.S. government when I got out of high school, and I finally went for the final interview, and I said, well, what do I be doing? Said, okay, you work on the actuators that start the motor that lower the landing gear on a B-52. I said, and what else? And they said, no, that's it. Every day? Yeah, every day. All day? Yeah, okay, I'm out of here. That's redundancy it'd be to an argument level. But like I say, there's always new challenges and new opportunities. There'll always be a need to determine the unknown. So challenges, as instrumentation improves, it's getting harder and harder to meet the limits that the government entities come up with that they consider to be the level at which they need to see analyzed for. I've got an LCMS, the high point of my curve is 0.2 parts per billion. So I'm running parts per trillion constantly. So like I say, the thing is, when you do that, that means we have to go buy new instrumentation. Well, that doesn't so big deal, go buy it. Well, you got to pay for it. That's the trick. It's like buying a car. It's not buying it's the problem, it's paying for it. Some of these instruments cost $100,000 to $250,000. So you got to run a lot of samples through them to make it work. But the thing is, we're constantly evolving and we're constantly doing that. The other big problem we have is less than reputable laboratories out there cutting their prices. They'll run a BOD for $9. Well, we run it for $12. Not a big deal, but if you run 1,000 BODs a year, that's $3,000. The trouble is they're not doing it correctly. But, people don't look at that. Oh, wrong way, Carter. The other thing is we have to constantly make sure the data represented is factual. We have to purchase that equipment, like I said, and there's a lot of regulations, but that's fine. New hires, like I say, after that is good. I'll stop there at 38 minutes after, and if anybody has any questions, I'll be glad to try to answer them.
Questions for our speaker? Oh yeah, that's clap. Hey, questions for our speaker? If they've tested local internal water of late, have you?
I don't know. I don't see them anymore. I used to see on here all the stuff looking at the results. But we have done a lot of testing, especially the last couple of months. Our sample numbers have been up primarily because of lead and copper testing. And a lot of the school districts and what have you. Those of you that are in this room are not old enough to remember, but they used to use a lot of lead pipe, especially in drainage systems. Wasn't used as much in water systems, but that's what happened up in Flint, Michigan. They had a bunch of old pipes that were put in probably back in the teens or 20s, and they were lead pipe. They used them a lot up north because when the soil freezes and thaws, lead will give. It'll it'll give so it won't break. Where if you have metal pipe or concrete or anything else, with the terrible shrinking and swelling they have with freezing and thawing, it breaks the pipes. So it was a good idea, but it was a bad idea. They didn't look at the potential for that. Lead is, we've known for years, ever since lead paint. I breathed a bunch of it when I was a kid, and I worked at a paint shop painting using lead-based paint. It's probably what's wrong with me. But like I say, it is bad. People need to be careful with it, and it is out there, and they need to address it. The worst thing, what happened in Flint, people tried to sweep everything under the rug. They knew they were wrong. It was wrong, and they said, well, let's turn our back on it. It'll go away. Well, they shouldn't have ever done that if they knew that was there. I will say that as far as I know, most places around here, unless most of the old school buildings have been replaced, and they now have PVC or steel pipe in them. So like I say, it's not much of a problem. But in some of the older houses, older schools, and what have you, they need to be testing that. Most of them have. They've taken it upon themselves, even though the government was back there urging them pretty hard. So.
Other questions for our speaker?
Yes, sir.
Have you heard of the situation in Pitcher, Oklahoma?
I've just heard about it on the news. I haven't checked into it. What is actually going on, do you know?
I heard that a while ago. They, when the town was founded, it was a lead mining town, and then when the lead mines closed down,
They built a town on it.
yeah, and then they started a bunch of bad environmental stuff over there.
You know, that's the thing. I'll have to say that most of the problems that we're facing with this is ignorance. It wasn't people intentionally trying to hurt anybody. But like you say, there's a lot of mining towns that whether they mine for lead or not, they may have cadmium or lead or God knows what. And like I say, they close the mine and they build something on it. Somebody drills a well down through it eventually or something, and all of a sudden they've got enough lead to glow in the dark, and they're trying to figure out where it came from. Well, it was because back in those particular days there wasn't any regulations on closing a mine other than the fact that you covered it up. But there are several places like that. Most of you. There's been some cases of pesticide contamination from back in World War II and even Vietnam where, they had pesticide contamination and they tried to hide it instead of fixing it. Those are called Superfund sites that the EPA is still trying to get cleaned up. But we work a lot with the DOD and some consultants that work with the Department of Defense where there's several old munitions plants around East Texas. Fortunate thing is most of the stuff that gets, it won't get in the water. Number two, if it did, it wouldn't hurt, but it's not safe. TNT at a fairly high level will bang pretty good. So, but like I say, I have to share a story. I got a sample in when I first came there, and they asked me to take care of it because it was from Department of Defense, and I went in there to start grinding it, and it started smoking. And I'm going like, whoa, and found out that it had percent level, some particular compounds, explosive compounds in it. So, you have to be careful. Sometimes people send you stuff that they need to tell you what's in there before it comes. The worst thing that can happen in an environmental lab is somebody sends in a sample and say, I want to know how much methylene chloride's in it, and they don't tell you it's methylene chloride. And because these instruments, the top point on our curves are usually 250 parts per billion. Well, okay, 10% is 100,000 parts per million. So you can imagine what that does to a detector. Take the instrument apart, clean it, bake it out, try to get it clean. So we've learned to be very skeptical of some clients when they send stuff in and they want to know that. They don't tell us what they're trying to do. We're looking to see if there's anything else in there besides that. Other questions?
Could you also use faster, coarser instruments to get a rough estimate to make sure?
We can, but as an environmental lab, most of what we do is residue type analysis. we don't actually advertise. Occasionally I'll do it, but we don't do assay type analysis because of the fact that for us to do an assay analysis, we may have to make a 500,000 dilution on it. Well, to make a 500,000 dilution, you're going to have to do a serial dilution, which means you have to dilute it more than once. Well, every time you do that, you add an error, a potential for error in there. And by the time, you take this little bitty number and multiply it by this huge number to get the answer, it may not be as accurate as what they need. For if we had instruments, for instance, I used to work for the company, our ICP was in parts per million, where ours is in parts per billion. We ran a different type of curve because we didn't care if it was in their parts per billion. We just wanted to see what the level was for a different reason. But we don't have the opportunity to do that. But because every one of these instruments that I put up there, if it doesn't run every day, it runs 4 days a week. So like I say, it would be a luxury, it'd be nice to have, but we don't have that capability to have what we do that, what we call it, and that is put in a high curve level in there where we can do that. But you can saturate a detector pretty easily on these. Good point, though.
How about fracking in this area?
I don't get involved in that. We've ran a lot of tests for people who thought that they might have methane or ethane or something getting in their water samples, and I can't attest to where the samples came from, but for the most part of what I know, I don't think we've ever found anything deleterious in the sample. A lot of people think so, and they find out, well, it smells like methane. Well, actually, you've got a little bit of sulfide in your well, which hydrogen will make hydrogen sulfide, smells like rotten egg, smells like methane. Has nothing to do with methane. It's just the fact that you have a bacteria in there that produces it. So that's most of what we find. We haven't found any, to my knowledge, we haven't found any where there's been any kind of creep into the water system with any of the results of fracking. Not saying there isn't, I just said I haven't seen them. But I don't think it'd be much of a problem. Most things that I see here in East Texas are maybe old saltwater injection wells that were drilled in 1930, and the casings got a hole in it at 100 foot. They were injecting salt water in it and thinking it was going 400 foot and it was going 30. But those have pretty much all gone away because they don't allow that anymore. But there's some salty areas around that were caused by that. But other than that, I haven't really seen any. I'll put it this way. Every water municipality and water people that we run for, I haven't seen anything that would be deleterious at all. And in fact, before somebody brings up Tyler about haloacetic acids, that was a one-time deal. Most of the time, your limit is 60 parts per billion. The safe level is about probably 50 parts per million. But, the government likes to keep it safe. I agree with them. And that was a one-time thing. What happens a lot of times, especially even the water around here, it comes out of Sabine. When all the leaves fall into Sabine in the fall, well, like I say, all of a sudden you start having an odor in the water. That's primarily geosmin, which is a naturally occurring thing when leaves rot. But like I say, everybody's very careful about it, and for the most part, I'll have to take my hat off to most of the water municipalities and water control districts. They do a real good job for the most part.
All right, well, that's a very positive note. So maybe with that, we'll end our day.
Thank you very much.
One announcement before you go. Remember that tomorrow we have another seminar. It'll be at 1:30 in the Education Building. Department of Energy will be here, and they want to recruit you for summer fellowships as well. So come out and bring a friend. Yeah, 1:30 Education Building tomorrow.
That was good.
Thanks a bunch. Thanks a bunch.